Hello, I am Dr. Lalitha Eswaran, Assistant Professor, Department of Chemistry, Trinity College for Women, Namakkal. I am going to speak about heteropolyacids. Heteropolyacids are formed from different types of anions which condense together, that is, molybdate or tungstate groups with phosphate, silicate, or borate groups. The principle underlying the formation of heteropoly anions is that the anion of the second acid provides a central group around which octahedra such as MOO6 or WO6 condense by a process of oxygen sharing. It is important to note that the central group phosphate ion also share its oxygen atoms with surrounding octahedra. A variety of elements can act as central atom in heteropolyacids. They include many nonmetals and many transition metals. In these ions, the heteroatoms are situated inside the cavities or baskets formed by MO6 octahedra of the parent metal atom and are bonded to oxygen atoms of the adjacent MOO6 octahedra. The heteropolyacids are classified in terms of the ratio of the number of central atoms to the number of metal atoms associated with the surrounding octahedral. Four major classes are found. 1 is to 12 tetrahedral. These occur with small heteroatoms such as phosphorus, As, Si, Ti, which yield tetrahedral anions. Some important members of this class is given here. 2 is to 18 tetrahedral. If solutions of 1 is to 12 anions are allowed to stand, 2 is to 18 ions are generally produced. The ions is best considered to be formed from 1 is to 12 anions, each of which loses 3 MO6 octahedra before fusing together. 1 is to 6 octahedral. These are formed with larger heteroatoms which coordinate to 6 edge sharing MO6 octahedra. Example is given here. Result from a ring of 6 octahedra about the heteroatom. 1 is to 9 octahedral. The structures of these ions based on edge sharing MO6 octahedra. Example is MO9O32 6 minus ion. Structure of heteropolyacids. 12 heteropolyacids. The structure of this acid is often called as Kegin's structure. The first structural study was made on 12 phosphotungstic acid. The central PO group is surrounded by 12 WO octahedra. Each corner oxygen atom of the PO group is shared with 4 octahedra, each of which also shares one oxygen atom with its two neighbors. The octahedra are further linked together by sharing corners. The same structure is found in a number of heteropolyacids based on elements other than phosphorus. The structure is given in this slide. 6 heteropolyacids. In 6 heteropolyacids, the central atom is larger and capable of coordinating with 6 atoms of oxygen. 6 MO6 octahedra are arranged in hexagonal annules so as to share two corners with each of two neighboring octahedral. The central cavity of resulting ion structure is found to be just large enough to accommodate an octahedron corresponding with that of heteroatom. This structure was identified in potassium and ammonium molybdotellurates which contain TeMO6O34 6 minus ions. The structure of 6 molybdotellurate is given in this slide. 18 heteropolyacids. The structure is called Dawson structure, which is given in another slide. Heteropoly blues. Anions of Higgins 1:12 and Dawson 2:18 structures can undergo reduction to intense blue mixed valence species without loss of structure, known as heteropoly blues. These reduction products are formed rapidly. These heteropoly blues find application in quantitative determination of silicon, germanium, phosphorus, and commercially as dyes and pigments. The structure is given in this slide. Thank you.